In this question, we have an elevator whose mass is given by 920 kg. It can carry a maximum of 10 persons with an average mass of 68 kg. The frictional force is 6000 Newton and it moves with a constant speed of 3 meter per second. We have to calculate the power delivered by the motor to the elevator when it is moving with its full capacity in the upward direction. This is a simple question from work power energy. So the power delivered is equal to force times velocity. We have to calculate the net force and multiply it with the velocity 3 meter per second. So what are the forces involved? We know that the lift is moving upwards, so it has to do work against gravity. So the weight of the lift plus the weight of the maximum capacity, that is 10 persons with an average mass of 68 kg. So 68 kg weight plus 90 kg weight plus the frictional force 6000 Newton. So the total force will be equal to 920, that is the mass of the lift, plus 68 kg mass average for a single person. So the full capacity will be 10 person, and the question it is given that the acceleration due to gravity can be taken as 10 meter per second square. So the total force will be the sum of all the weight. That means weight of the lift plus weight of the passengers plus the frictional force due to it. So 6000 plus 680 plus 920 multiplied by 10 will give 22,000 Newton. So this is the net force, and the power delivered by the motor to the lift will be force times velocity. So 22,000 multiplied by velocity, which is given as 3 meter per second. So the answer is option 4, 66,000 watt. In this question, an ideal fluid flows through a pipe of non-uniform cross-section. Here it is given that the maximum diameter is 6.4 centimeter and the minimum diameter is 4.8 centimeter. So for this laminar flow, we have to find the ratio of minimum to maximum velocity. So this is an easy question where we can apply the equation of continuity. So from the equation of continuity, we know that when fluid flows through non-uniform cross-section, the velocity will be maximum where the cross-sectional area will be minimum. Therefore, the ratio of minimum to maximum velocity is V1 by V2, which is equal to A2 by A1, as it follows from the equation of continuity A1 V1 equal to A2 V2. This is arising from the fact that the mass of fluid per unit time across the cross sections are equal. By substituting the cross sectional area, which is minimum, is 4.8 divided by the maximum cross section, which is 6.4. Now this cannot be the answer because this is the ratio of the diameters. We have the cross sectional area, so it will be pi d square. So in the ratio the pi cancels, so the ratio of the areas will be equal to the ratio of the diameters, 4.8 by 6.4 square. So it is same as 48 divided by 64 the whole square. That is 16 multiplied by 3 is 48 and 16 multiplied by 4 is 64. Therefore 3 over 4 the whole square, 9 by 16. 9 is to 16, and so is option 1. In this question, we are having a plain wire loop which is in the form of a circle rotating in a uniform magnetic field. It is given that this planar loop rotates about an axis passing through its plane with a time period of 10 seconds. And also it is given that initially, that is at t is equal to 0, the magnetic field is perpendicular to the plane of the loop. So we have the magnetic field perpendicular to the plane of the loop at t is equal to 0. And the time period for rotation is 10 seconds. We have to calculate the instance at which the induced EMF is maximum and minimum while the loop rotates in the magnetic field. Now, EMF will be induced because the magnetic flux associated with the loop changes as it rotates in the uniform magnetic field. The magnetic flux associated will be given by phi is equal to BA cos theta or B dot A, where theta is the angle between the magnetic field and the area vector. Now, the induced EMF is equal to time rate of change of magnetic flux. Here the magnetic field is constant, area is constant, and the factor which changes is the orientation of the loop with the magnetic field, which is given by theta. So the EMF will be maximum when the flux is minimum and vice versa. So we can say that at t is equal to 0, the plane of the loop is perpendicular to the magnetic field and it rotates in 10 seconds. So the flux is now maximum. The flux will be minimum when it rotates through 90 degree, that is the plane of the loop is parallel to the magnetic field. So this can be illustrated like this with a loop and the magnetic field. So if the loop is in this orientation as given at t is equal to 0, it takes 10 seconds to have one complete rotation. So the flux is now maximum. The flux will be minimum when it turns by 90 degree. So for one complete rotation it takes 10 seconds, and for to rotate by 90 degree it takes 2.5 seconds. So now the flux is minimum, so the flux change is maximum, that is from a maximum value to 0 value. So induced EMF will be maximum at 2.5 seconds when the flux is minimum. And similarly, induced EMF will be minimum when the flux is maximum while it rotates through another 90 degree, and that is at 5 seconds. So the answer is option 4, 2.5 second and 5 second. This question is from the chapter Wave Optics. We have a Young's double slit experiment arrangement where the distance between the two slits is given as 0.15 millimeter and the source has a wavelength of 589 nanometer. The pattern is obtained at a screen placed at a distance 1.5 meter from the two slits. We have to find the distance between two successive bright bands. That means the width of a dark band is to be found out, which is given by beta, the fringe width, also known as the band width, is equal to lambda d over d. This is a direct application question. So we have the wavelength given by 589 nanometer multiplied by the distance to the screen, capital D, as 1.5 meter, and the distance between the two slits as 0.15 millimeter. So we had to convert into meter, so 0.15 into 10 raised to minus 3. So all these are in meter, so the answer also will be obtained in meter. So this is 5.9 into 10 raised to minus 3 meter, which is 5.9 millimeter, and the answer is option 3.